Today we're going to be talking about electromagnetic radiation. The sun, for example, gives off electromagnetic radiation, and you often hear words like radiate in reference to heat and light coming from the sun. Light, then, can be described as radiation and behaves like a particle, and, more importantly to what we're discussing here, waves, like the ones you observe in the ocean. Waves have two distinct features, wavelength and frequency. Wavelength is defined as the distance between two successive crests, marked here. Frequency is a bit more complicated. It is the rate at which the crests of a wave pass through a given point, usually measured per second. As you can see here, wavelength and frequency are related. The longer the wavelength, the lower the frequency. Also, the shorter the wavelength, the higher the frequency. Frequency and wavelength both relate to speed. Speed can also be thought of as energy. Think about it. Does a race car moving at high speeds have more or less energy than a bicycle moving at lower speeds? You're probably leaning towards the race car. And you're right. The same inference can be made to electromagnetic radiation. Let's talk about the different types of electromagnetic radiation and their respective wavelengths. At the top of the list we have gamma radiation, coming in at 10 to the negative 12 meters. We'll talk about those sizes later. Next we have X-rays, coming in at 10 to the negative 10 meters. Next, there's ultraviolet rays, coming in at 10 to the negative 8 meters. Then our visible spectrum at 0.5 times 10 to the negative 6 meters. Then infrared 10 to the negative 5th, microwaves at 10 to the negative 2nd, and then radio waves at 10 to the 3rd. Gamma rays can be compared to the size of a nucleus of an atom. X-rays can be compared to the size of the entire atom. Ultraviolet light is similar in size to molecules put together. Our visible light is similar in size to bacterial cells or small protozoas. Infrared light is about the size of the head of a needle. Microwaves are a little bigger and can be compared to maybe insects or even humans. Radio waves can be as large as skyscrapers. So as you can see, electromagnetic radiation comes in many different sizes. Let's talk about the light that we can see. Our eye is attuned to see very specific frequencies. At the top we see purples, close to ultraviolet, then blues, greens, yellows, and reds down by infrared. Our vision can only register the wavelengths from 400 nanometers to 700 nanometers, so that's a lot we're not seeing. An easy way to remember what has more energy in our visible spectrum is that purple is close to ultraviolet, which has more energy than red, which is close to infrared. There is a brief summary of electromagnetic radiation. Good luck!